Developer productivity is probably one of the biggest topics right now. Today, I'm joined by Anish, who's co-founder, CEO of Cortex. We're going to be exploring the world of developer productivity portals, how imperative they are, and the value creation of having something like Cortex. Anish, take it away. Give us a bit of a background intro into you, but also talk to us a little bit about Cortex and the problems that you're solving.
Yeah, absolutely. Thanks for having me. So I'm Anish. I'm the co-founder and CEO of Cortex. My background comes from engineering at Uber, where I spent a few years working on products like Uber Eats. Uber is like the classic case of microservices gone wrong. I remember at my time there, the services just on my team went from around 30 to over 3,000. And with that came a whole set of different challenges. I mean, everything from understanding who owned different services to services being named after Game of Thrones characters, which meant if you're a new engineer who joined the team, it was practically impossible to understand the context behind these services, who previously built them. Engineers come and when they leave, they take all this institutional knowledge with them about how these services work and which APIs are critical. And documentation was scattered across 7 or 8 different tools, whether it was Google Docs, Confluence, or just internal tools that teams had built and in many cases stopped maintaining. And so Uber is obviously on one end of the service complexity scale, but I was talking with 2 close friends of mine. One was an engineer at Twilio and the other at a smaller startup called LendUp. And we came from 3 very different sizes of companies, but everyone had the same challenges around understanding and defining services. And we were all using spreadsheets or internal tools to track all that data. And so we ended up starting Cortex. We went through the Winter 20 Y Combinator batch a few years ago. And then fast forward to today, we just raised our Series C about 6 months ago, work with hundreds of different enterprises who use Cortex to manage service complexity. Really, the problem starts once you have 50 to 60 engineers. You start either, it's like everyone agrees every company is a software company. But what's also become true is software is just inherently more complex, right? It's not just microservices, it's your databases and your cloud infrastructure and even things like third-party vendors that all have different pieces of context and owners behind them. The reality of it is, as engineers have been using tools like Jira and Confluence to track that information, but it just goes out of date and then has all these implications for developer productivity over time. And so really that's the reason I think products like Cortex exist and why the market has been growing.
Love it. Great intro. Walk us through, if a company was to integrate Cortex into some of their systems, help us understand the role that Cortex would actually play in that business and how you can actually understand what your services are, where they are, and how it actually works.
Yeah, absolutely. So the average engineering team has close to 12 to 20, sometimes 30 plus different tools that they're using. They kind of span the entire like SLDC life cycle. Like you have your APM products that do observability, you have your on-call tool, you have your Git, your security scanning tool, right? You have all these different tools that have different functions, but that's also like an enormous amount of tools to keep track of as an engineer. It can be a lot of context switching as well. So Cortex is basically able to integrate with all of these tools, whether it's on-prem or cloud. And we basically build almost this knowledge graph of all your tools, systems, and people. And we can do that using different models that we build. You also have this like kind of self-serve onboarding flow that can kind of surface services that we find and the connections that we think they have to all your different integrations. And once you have that data inside of the product, the really interesting thing about Cortex is that it's a system of record that has a lot of application and data inside of it that becomes useful to a lot of different people. So for example, in a typical customer, you have developers who are using the catalog to understand owners of services when there's an incident. Or if you're a new engineer joining a team, we can give you this almost single pane of glass that helps you understand your services, all the different PRs that are open across your teams, any incidents that are ongoing, and you get this almost health check of all of the services and of that you own, and if there's any alerts or things that you should be looking to immediately. And then you have uh, uh, personas like SRE, security, platform, who typically use the product to enforce best practices. So we have this product called scorecards that lets you basically define a set of standards. And so a common scorecard could be production readiness. For most organizations, production readiness is a mission critical thing because 1% of downtime means millions of dollars of loss for your customer. And so you want services to be production ready. But the reality of it is your SRE team is using Confluence to document that production readiness process. What that really means is that engineers aren't following it. And then as a leadership team, you have no way of understanding which teams are at risk or what services are at risk, especially when you have like 10,000 services. And so with Cortex, you can automate all of that. And that's what really drives a ton of value for those SRE security teams. And then leadership end up using the product just to get this understanding like across the entire organization, where the areas of risk from a reliability, security perspective. Are we making progress towards our OKRs? We kind of give you this bird's eye view into how the organization is doing. And so it ends up kind of being impactful to a lot of different personas.
Yeah, I love it. I think the single pane of glass, when we first met, we were talking about almost the observability of your software, systems, services, databases. That really helped me understand it. That comes with complexity, which you and I have spoken about. We're obviously on this journey now of introducing AI, different tools, different developer co-pilots, etc. What are you seeing from your lens that's happening in different software teams across businesses, the burns, but also the positives?
Yeah, it's the $1 million question, right? It's the question that every single CTO and VP of engineering is being asked in the boardroom today. It's kind of a two-pronged thing, right? Like, one, are you using AI to boost the productivity of your engineering team? And the answer to that should be yes. But then the question that is followed up with that is, hey, you're spending $10 million on Copilot licenses. Are you seeing $10 million plus of actual ROI and productivity? And so that's kind of the place I think most enterprises are in right now. And it's a tricky place to be because the answer is, I think, complicated for different organizations of different sizes. And we're seeing this reflected in our own customer base as well, right? Like the number one thing that we get asked from our customers is, hey, are we actually seeing the ROI of these different tools that we brought in? And I think our perspective on it is kind of reflected on how we look at AI in our own engineering team today as well. Like there's no doubt that tools like GitHub Copilot and Cursor can boost the productivity of engineering teams, especially teams like front end, or when you're a small startup and you're trying to iterate and find product market fit and you want to quickly get something out. I mean, there's no better utility than these products that can make an idea come to life and present that to someone in a very, very concrete way, right? Like those use cases I've seen it's accelerated those by order like magnitude of like 10x productivity, right? But it starts to get tricky when you're using these like AI systems in production, especially when that production system has like expectations around performance and is powering a very critical part of your system. I mean, the reality of it is that these AI systems produce code. They produce a lot of new code, and sometimes you don't always have full context behind all the different lines of code that they're producing, because and we've seen that with our own customers as well, right? Which is like, maybe it all depends like how you view productivity. Like if your main metric of success is like what percentage of code in my system is being contributed by AI, or how many lines of code is AI writing, then it's probably gonna look like AI is doing a lot for you. But then there's all these like side effects of that. For example, okay, yes, we're writing more code with AI, but is our reliability going down because when something breaks, engineers have less context about the systems that were not written by them at the end of the day? Those are kind of the higher level questions that I think become a little bit more tricky and things that you have to navigate, especially when you do have a lot of customers, when you do have SLAs that you have to meet. And so I think we're seeing this, of course, like we want our engineers to use AI. It's clear that this is where the world is heading. AI native startups are moving faster, but there is a limit to building high quality production systems that AI systems don't, AI coding systems don't understand yet, right? Could they get there? Maybe, but they're not there yet. And so you can't just blindly trust it, I guess. And so that those are the kinds of conversations that we're seeing on our end.
Love it. You're actually in a pretty prime spot with some of the customer base that you have, especially at an enterprise level. I see where this is becoming a challenge. AI native businesses, startups that can move really quick, you have the context of what's happening in the same room. But if you have distributed teams at serious scale with some really serious production stuff, that's where it's going to get really challenging. If we're not careful, where could we be in a couple of years if this continues, if spend continues, if we're developing code at the rate in which we're developing code and it isn't quality or production tested? Where could we be?
Yeah, I mean, I think you're starting to see some of that happen already where it's, when these systems and coding assistants first came out, you just constantly saw in the media, uh, hey, we're replacing our engineers with AI. Hey, we've cut 50% of our team because we've replaced them with AI. And then you started to see some of these companies walk that back and be like, hey, actually, we've rehired most of the people that we let go, or it's not made that much of an impact in terms of like how we think about hiring. And I think that's just the reality of it. Like I do think AI is a paradigm shift and a platform shift similar to when mobile first came out. And that has to be appreciated in terms of like what it can do for a business. But at the same time, I do think we're going to transition to a world where, it's not so much AI is replacing me, but AI is assisting me in very concrete use cases that make me 10 times more productive. Like AI certainly has a place in, like, for example, I bring up front end design, right? I mean, being able to go from a design to a mock-up is something that AI is exceptional at, and it does improve the engineering process because I can actually interact with the front end of it. I can see how it feels. I can show a customer. Those kind of use cases are phenomenal. But I think we're still, the idea that an AI system can replace a senior software engineer is just not true today at any company, despite what they say. And so I think you're going to start to see like this surge in uh, just the amount of, I think, software a company has. And by that, I mean like the code that they're writing or the different systems that they're building, because I think AI is optimizing for producing code, but it doesn't necessarily think about, hey, if I create this system here, it kind of looks like this other system here, so maybe I can erase that, right? Like those are kind of like the second order decisions that I think engineers are going to have to get better at recognizing. And the result of this at the end of the day is, if you don't have visibility into your systems, if you don't understand who's writing your code, it's only going to exacerbate like reliability issues, security issues. I mean, I guarantee you in the next 10 years, you're going to see some probably massive security gap that someone was able to expose because maybe a large part of production systems are being written by AI. Like that's the inherent risk I think that runs with all of this. So I think people just have to be careful and understand what's actually going on.
Yeah, I think it is really easy to get excited about how productive you can be, what you can build, how fast you can innovate. But I think you've touched on two interesting topics that we explored lightly, but increase of spend, unknown ROI at this stage, because I think it is still ambiguous, and security. And these are two fundamentals that I think have existed in building technology teams the right way, thinking about cost, thinking about security. Obviously, building a product today same as what it was 10 years ago. You still want to have those two principles front and center. So I do think it will be interesting to see how the world continues to shift over the next 6 to 12 months and where companies are placing bets.
That's right. I mean, the interesting thing to think about when you think about a developer's day to day, right? Most developers only spend 20 to maybe the at max 40% of their time coding, right? The other majority of their time is dealing with incidents, trying to ask questions about their code base, understanding code they haven't written, dealing with low quality code, refactoring, right? There's all this wasted time, I would call it, inefficiencies that engineers have to deal with before they can actually go in and spend high quality time coding. And it's not like we'll ever get to 100% because obviously there's, you take breaks and, there's things you have to do outside of coding that are equally as important. But there's so many inefficiencies that come day to day. And so sometimes I find it funny that the world is so fixated on that 30% of time, like optimizing that 30% of the time, because, well, what about the other 70% of the time that is truly sometimes wasted in these activities that I think could also be improved with AI? And if we could even bring back 10% of that and, add it to the amount of time engineers spend coding, I mean, the productivity gain from that additional 10% over all your engineers for a lot of enterprises is millions and millions of dollars. And so it's just interesting to sometimes see, like, I think AI assisted coding is like it's like cool. It's like sexy to talk about and think about. But if you're not also thinking about how do I improve the underlying systems or developer tooling or my new engineer onboarding process or this service has the worst SLAs, it's breaking every month and engineers are spending several hours a week trying to fix it. Like, those are the efficiencies that are almost more tactical and easier to quantify as wins than, like, hey, did my engineers produce 2 times as much code and what does that actually mean from an implication standpoint for my business? So I think we're going to see a lot more. We're going to see the pendulum kind of swing back in the other direction as well, I think.
That's probably the best response that I've heard in the last 3 months. I wouldn't say sanest. I'm not in a position to say sanest, but I think that is the most pragmatic response that I've heard. And your view comes from you're building that single pane of glass. You have that bird's eye view, potentially, of what's happening across multiple teams, multiple organizations to actually see what's working and what's not. And I think, next we're going to talk a little bit about where do you think developer productivity is going. But I think actually, instead of focusing on this paradigm shift of AI, think about the operational health of your systems and improve that. And you've got something to understand, as opposed to here is still relatively ambiguous.
That's right. Yeah, I think it comes back to just understanding the goals of your business, right? Like, and it's something we talk a lot about because one of the charters we have as a business at Cortex is helping companies think about engineering excellence. And engineering excellence is all about being able to take the technical initiatives we have ongoing and actually link them to real business outcomes that you care about, right? And every organization has different business outcomes, whether it's increasing efficiency or beating your competition, deploying software faster. And there's so many different ways to attack those business outcomes. But yeah, just like I do see it happen where there is a lot of pressure on these engineering executives to incorporate AI. And so it's the easiest thing to just say, oh yeah, everyone on the team uses cursor. And the reality of it is maybe your team is moving faster, but again, yeah, you have to think about it holistically. Like, what is actually bogging down our team today from moving faster? And there might be some more obvious wins to think through.
Love that. I actually really love that perspective. Where do you think we're going with developer productivity?
Yeah, it's interesting to see how this space has evolved. I mean, door metrics is still something that every CTO gets asked about. It's still something that I see constantly, even from our own customer base. Like, hey, I want to understand our door metrics, and that has its own purpose and place, of course. Like, it does give you a snapshot of engineering health, and there's various other things I've seen, like space and companies that are focused now on trying to help you define what quality looks like. But the reality of it again is productivity is an extremely subjective thing, and there's so many variables that go into productivity at the end of the day, right? Like, looking at, and everyone understands, I think, inherently, that you can't judge an engineering team just on a set of metrics, right? There's so many variables. I think the way we think about it at Cortex, and the way I think the market is headed, is you have input and output metrics. And so you have output metrics that are things like deploy frequency, right? Deploy frequency is a good heuristic to look at, because okay, maybe if we're deploying 2 times a week and we want to get to 4 times a week, so people are shipping more, maybe that means that we're shipping software faster, where then we can beat a competitor to market, right? But deploy frequency, there's so many, like, if you go to a developer and you show them a graph of their deploy frequency and you tell them, okay, we need to 2x this, go figure it out. Honestly, 99% of developers are gonna not care, and they're not going to know what to do to actually improve it. Yeah, like, of course I can try to work faster, but I mean, I have so many other things to think about. I have to ship software that is on my sprint for the business. Like, developers don't really care about metrics, and they, because I think they're presented in almost like this big brother, hey, the organization is watching and using these metrics to like give you a picture of your health. But the reality of it is just, it just doesn't really mean anything. And so I think what we found is you have to think about, how do you translate that into input metrics that influence that output metric, but mean something to a developer. And so, for example, I use production readiness a lot. Maybe the reason we're not able to hit our deploy frequency target is because we're constantly shipping code that doesn't meet our production readiness standards and breaks things, and we're rolling things back constantly, right? Like, diagnosing it from a first principle standpoint, and then presenting a explanation to engineers that actually can mean something in the context of the work they have. I think that's how we've seen not only the business metrics move, but then you actually build this culture as well of engineers owning things like reliability or security from day one. And I think that's fundamentally what executives should strive for, and what developer productivity, I think, should mean. Because at the end of the day, anyone who's listening to this, like, your SRE team, the ratio between your SRE team and engineering team is probably 1 to 20, right? It's just impossible for your SRE team to have complete and full context over everything engineers are building. And it's unreasonable to even ask them that. It's an incredible burden that these teams have to face, like platform teams especially. And so if you can have engineers think about the implications of the code that they're writing and how that's going to impact these different like things like production readiness, I think you start to build that into the culture, and productivity will improve, because engineers are thinking about the second order effects of their work. And so, yeah, I think productivity is just going to become more like less about Dora and more about these different things like reliability, security, operational efficiency, and just painting this whole picture of like, yes, we want our engineers to move faster, but what are the implications of that with respect to some of these other initiatives that we have going on?
Something that you said that particularly stands out, the relationship between inputs and outputs. And I want to ask you, what other points do you feel are really impactful when creating high performing, high excellence engineering teams? The thing that I love that you mentioned, especially around how can you actually bring back the end goal into an engineer's day to day? Like, how can we actually improve X by 2X to ensure that it's production ready and it doesn't break? Like, bringing something back to reliability. But the wider question being, what other tips in today's world do you feel that you'd give to engineering executives to really think about to create high performing teams?
Yeah, I think that it's a really good question, and like I think obviously every team wants to be high performing, and I would say that it's like breaking down the engineers day to day, and then I think it also just kind of goes back to thinking about what are the outcomes that we want to drive, both for the business and for the developers as well. Like for many years, even when we started Cortex, developer experience for the sake of developer experience was a huge thing, right? Like we want our developers to be happy, and so we're going to invest a ton of resources into making that a reality. And of course, developer experience is important. But what I've started to see is a big shift, and I think this is a very positive shift. And what I've seen work on high productive teams, high performance teams, is yes, our developer experience is important, but it's in the service of engineering excellence and to drive a business outcome. And so, for example, something like, yes, we want engineers to have all of their tooling easy to set up when they start joining a company. We wanted to make it as easy as possible for engineers to be productive on day one. But the reason for that has implications on things like retention and even things like productivity. Like time to first code is a metric that a lot of enterprises think about, and that metric for many enterprises can sometimes be weeks. I've even seen a month in some cases, and it's I think you have to really be able to, I think, break up, I think, the day-to-day of an engineer and kind of understand which parts you're trying to optimize, and not just look at it from a metric standpoint, but also like developer satisfaction and overall like I think even like the qualitative stuff can mean a lot sometimes. So I would say it's just being able to like draw this picture of your engineering organization, and also always try to link it back to some sort of business outcome that we're trying to drive. I remember, at least for me, was when I was an engineer, and I've seen this happen in a lot of organizations. Right, is when I'm able to understand how my work is driving something for the business, and that doesn't just mean like the engineers who are working on things that customers directly interact with, even like platform and teams that are doing a lot of refactoring. There's ways to be able to tell stories about the work that actually link it to actual business outcome. And we've just seen that being able to talk about that with the engineering team, which I feel doesn't happen enough, can create this intrinsic motivation to do more, and to own more things around like reliability or security. So I think it starts with understanding what behavior you're trying to drive, what outcomes you want, but then also being able to link that work back to this is what matters as a business. This is what we care about. And by the way, this is also a phenomenal way to not only get buy-in from the engineering team, but from peer executives who aren't in engineering. Right? How do you communicate why a production readiness checklist is the most important thing to work on to the CEO of your organization? Because realistically, they're not going to fully understand what the implications of that are, or why that matters, or why engineers maybe shouldn't focus on like a few sprints on the work that's visible to the customers, right? Like, how do you get buy-in on these platform initiatives? I think it's when you're able to talk about it in relation to something that the business is trying to drive as an outcome, like customer impact. Those are things that other executives will care about too, and I think that's just how you kind of build this culture of high performance.
Love that. I like that end to end, actually. Maybe it's not spoken enough about onboarding, retention, satisfaction, but a way to be able to track that is obviously being your 1 day metric through to a month. But I think they are, like you say, really important things to build a happy, high performing team that I think are often overlooked. But again, I particularly love your point around the relationship between the inputs and the outputs, and understanding what the outcome is that we're trying to create for engineers. It doesn't need to be that customer impact in delivering a feature that sits maybe on someone's mobile phone, but it could be focused around reliability and security. So I think there are some really interesting things there for engineers, engineering leaders who are listening to be able to reflect on their own work or how they can actually impact some of the teams that they may manage or serve.
That's exactly right. Yeah, I completely agree on that.
Where are we going in the next 3 to 6 months? Where are Cortex even placing bets on how you can be ahead of the curve for where developer productivity will be, creating high performing teams? What are you guys doing?
Yeah, I mean, it's definitely been a huge focus for the company. We have an entire product suite called Engineering Intelligence, where the idea is being able to understand productivity across all these different lenses. And a big focus for us is being able to talk about productivity in the context of initiatives like reliability and security, and being able to kind of bring it all together in a meaningful way. Because I think I feel developer productivity as a space has been too focused on metrics and not also thinking about the implications of how those metrics actually change the culture and drive behavior on the engineering team. And I think that's why there's honestly been a lot of dissatisfaction with engineering leaders who buy tools who claim to do these type of metrics analysis, because at the end of the day, it's like it's pretty easy actually to get a dashboard of my Dora metrics. It's way harder than convincing the engineering team that those metrics matter. And I think that's where this whole market is headed. That's where Cortex is headed, is being able to tell that story in a way that motivates engineers and gets them thinking about it from day one. And I think that's truly how you solve developer productivity. And I think that's what we're focused on now.
Love it. Love it. Walk us through, if you are looking to grow the team, what you're looking to potentially grow the team with, and even if you can share in confidence, maybe some of the engineering challenges that if an engineer is to walk into Cortex's office today and hear teams talking, maybe a problem or two that they might be solving.
Yeah, absolutely. Yeah, I mean, we're constantly hiring and growing the engineering team, and we actually even have an office in New York where a bunch of the engineering team works out of. We're fully remote, but still have the opportunity to work a lot in person, which I really appreciate. I think working in engineering at Cortex is super interesting because there's so many types of different problems to work on. I mean, we get to work with some of the world's most well-known engineering organizations. I mean, companies like Netflix and Canva, and it's really incredible getting this perspective of how these different engineering teams operate and what are the engineering excellence problems that they're trying to solve that they're using Cortex for. And as an engineer at Cortex, and this is something that I really appreciated when I used to work at Uber, is you're very, very close to the customer. And the really cool thing about this category, internal development portal, is that it didn't exist 5 years ago, right? It's the first, it over the past 5 years, it's really materialized as a market. And what that means is the people who buy the product, they're buying it. They've never bought a product like this before. It's the first time they're ever using something like Cortex. And what that means is like they have this incredible enthusiasm and appreciation and support for the product and the team behind it. And so as soon as you ship something, pretty much the same day or the next day, there is usually like 70 to 80% of our customer base who adopts it, who immediately gives feedback. And if you're excited by that product driven development, I think it's honestly like one of the most exciting places to be, just based on that. But then if you're also interested in scalability or building performance systems, I mean, some of our customers have tens of millions of services across their Git, their AWS, they're often multi-cloud. You have enterprises that some teams are very modern, but some teams, their services are still on-prem racks built 30 years ago, and everything in between. And so you're constantly exposed to this mix of, like AI native companies that are buying Cortex because they know their AI systems are building a ton of new services and they want a system of record to keep track of all of that, all the way to large enterprises that are trying to modernize and become cloud native, and they're using Cortex to kind of drive that culture. So that's, I think, probably the most exciting thing to get exposure to. And we're sitting on this mountain of interesting data and analysis, and uh, for me, that's the most interesting application of what AI can do for Cortex, because I think we're in the business of helping engineering leaders build high performing teams, and we see all of this data on what makes high performance happen. And I think we can help guide or recommend or influence these leaders on what that looks like. And so I think that's kind of how I see AI playing a role here.
Love it. It does sound like a sick opportunity. Like how you've just laid it out in terms of the perspective, the understanding of where some of these incredible engineering teams are focusing, how they're building, where they're placing emphasis on, through to our new age AI native businesses and how they're approaching problems. But your typical engineering challenges of scalability, reliability, and thinking about being very product driven. So that's my little pitch back to everyone listening. Check out the careers site below, and you'll be able to get in touch with Anish and no doubt have conversations in regards to some of the problems that Cortex is solving. You've been top. Thank you so much for coming to join us. I do really appreciate it. And I think for people listening, go and check out Cortex. Go and have a look at maybe introducing the platform or having a look at some of what they've got to offer on their career site.
Yeah, thank you so much for having me. Yeah, you can just go to cortex.io or email me, anish@cortex.io, if you have any questions or want to chat about what it's like working here. But yeah, thank you so much for having me on.
Absolute pleasure. For people listening, all your likes, shares, subscribership, all that good stuff keeps this little ecosystem going round, as you know. Continue doing that. Again, Anish, you've been a legend. Thanks a lot.
Thank you so much.
Hey guys, thanks for watching this episode. Massively appreciate you listening and checking in with us. If you want to find out more about us and what we're doing, please check us out on social media. What we're trying to do at Engineers is build a community to drive knowledge sharing and experiences. On Twitter, we can be found Enginears.io. It's no underscore. We've also got a website, which is Enginears.io. These links will all be posted in the description. Any feedback and comments are massively appreciated. We're always looking to improve on where we can. Thanks, guys.